A very good morning, all of you. I'm Dr. Reeta. Today, I will be teaching a chromatography technique under Analytical Techniques in Plant Sciences. So, the name of the paper is Analytical Techniques in Plant Sciences, and within that, we are going to study one unit of it, that is chromatography. There are various types of chromatography which will be covering in this topic. We will be studying principal paper chromatography, thin layer chromatography, column chromatography, gas liquid chromatography, HPLC, ion exchange chromatography, molecular sieve, affinity chromatography, and all in this chapter. Now come to the point that what is chromatography? Chromatography is a combination of two words, chromo and graphy, where the meaning of chromo is color and the graphy means the graphical representation of something on the paper. So the two words together known as chromatography is nothing but a color representation of anything. It can be amino acids or pigments or anything on the paper. Let's go back to the history of the chromatography. A Russian scientist named Mikhail Svet in 1903 discovered this chromatography technique for the first time in first decade of 20th century. What he did the separation of the plant pigments such as chlorophyll A, chlorophyll B, carotenoids and xanthophyll using these techniques. Since these components have different colors, green, chlorophyll A and B are green in color, oranges, carotenoids and xanthophylls are yellow in color, they gave different name to these pigments, and these are nothing but the photosynthetic pigments. So these pigments are responsible for photosynthesis process, and he was the first person to get this pigment separated on a piece of paper. You can see in this one. You can see here, this is the chromatography paper, and on the chromatography paper you can have separated chlorophyll A, chlorophyll B, xanthophyll and carotenoids. These are the, you can see the various pigments are present in the leaf. You can see the leaf has different pigments, and which pigments they have, you can see the structure also. So the different leaves have different colors, but basically they all have these major four pigments, which is chlorophyll A, B, carotenoids and xanthophyll. So he devised this technique. There are various definitions of chromatography. Basically, according to IUPAC definition, it is a physical method of separation where the components we are separating are separated between the two phases. One is stationary phase and the other is the mobile phase. So you have two phases, mobile phase and stationary phase. As the name indicates, the stationary phase is always a stationary thing which will not move, which can be a solid, a liquid or a gel. While mobile phase, as the name indicates, mobile means something which moves on. So which moves on can be a gas or it can be a liquid. So it is a separating method where the components are separated between the two phases, stationary phase and mobile phase. So you can see this. We are going to separate a mixture. Which mixture, suppose for example you have the mixture has these four components, the yellow ones, red one, blue one and the black one. So we are going to separate this mixture into different components. The purpose is to analyze, to identify, to purify and to quantify what the mixture or component has. So for example, you have a mixture, you have separated those and we got the various component by using this chromatography technique. So after doing this we can analyze, yes, the which is the size is bigger, which one is smaller. We can identify that yellow ones are this, blue ones are this, red ones are then these, so on and so forth. So to analyze, within analysis we examine the mixture, what are its various components and what is relation to each other. To identify, we determine the identity of the mixture or the component based on known components. To purify, we separate the components in order to isolate the interest of further studies. And to quantify exactly वो component कितना present है, how much the amount it has, the mixture has. ठीक है, so that is the four basic criteria of chromatography. You can see the illustration of chromatography when we will run a mixture. The solvent, which is the mobile phase, you can see here, this is the solvent. The mobile phase will move upwards. As in when it moves upward, this is the stationary phase. Generally, the stationary phase is Whatman filter paper in case of paper chromatography. As in when it will move, the components will separate out depending upon their affinities with the mobile phase, with the stationary phase. So they are moving in different direction, different rate. As you can see, the yellow ones are bigger in size, but still they are moving faster because they shows more affinity towards the mobile phase as compared to the red ones or the blue ones or the black ones. However, the blue ones remain at the origin point because they show more affinity towards the stationary phase. So these are the components you can see here: black, blue, red and yellow, and these are the affinities of towards of these components towards stationary phase and the mobile phase. Now, to summarize this, that chromatography is a separating method where we have two phases, mobile phase and a stationary phase. Mobile phase is also known as a solvent, which can be liquid or a gas because they only the things which can move. Stationary phase is also known as sorbent, and it is either a solid or a liquid. It cannot be a gas. The solid holding the liquid stationary phase is the supporting or matrix. Generally हम जब use करते हैं TLC में, we use thin layer chromatography where we use a solid support on which we load silica slurry. So that acts as a solid or matrix. Then the molecules in the mixture to be separated. This is what we need in the chromatography technique. Now there are three types of directions, you can say. It can be radial direction by which we can separate, where you will do the loading here and the molecules will move in this direction. You can see here they are moving in these directions, so it is known as radial one. This is the most common type which we prefer is ascending type, where we keep the solvent here and the solvent will run upward against the gravity. So this is known as ascending type. And descending type, where we keep the solvent on the tank upper side and we hang the paper or strip downwards towards the gravity, and the movement of the molecules is towards the lower direction. So this is known as descending one. Now there are various types of chromatography. It can be paper chromatography, thin chromatography, liquid chromatography, gas chromatography, gel filtration and ion exchange chromatography. There are so many chromatographies. We are going to discuss chromatography, paper chromatography. So this is the setup where you can see the solvent, the Whatman paper and the direction of the movement of the mixture. This is a substance which we want to identify. So this is the mixture. As the solvent moves up to the paper, different molecule will different rate will move differently, and the smallest molecule will move faster. This paper chromatography technique is used for smaller molecules such as amino acids, sugars. Now what you have to do, let's talk about the procedure now. You have to take a strip which is a Whatman filter paper. You will make a line on that which is known as origin, where you will do the loading. Suppose we have loaded these three components, red, blue and green, and then we have poured the solvent in a jar. We have covered the jar with the lid so that the jar is saturated, and then we will allow it to run. When the paper have run 2/3 of it, you will stop or take out the paper. You can see the movement of different molecules depending upon their affinity with the mobile phase. So we can say that the blue one has more affinity towards the mobile phase as compared to red and green, and followed by green. Blue is the highest one, second followed by green, and the last one is the red. The red shows more affinity towards the stationary phase, that's why its movement is very slow. The second factor can be the molecular weight. the size. Because it is heavier, it is not able to move. So when you have run the chromatogram, before running the chromatogram, you have to take a strip. You will mark origin. This is origin. Then you will place the equidistantly the various spots. Then you will load the amino acids. Suppose we have loaded different amino acids. We will allow it to run. It will run. We will get the solvent front and we will mark the solvent front, and later on we will get the various spots. So you can see that this amino acid reached to this place, this amino acid has reached to this place, different amino acids have reached to different place. You can see here this one, this one, this one, this one, likewise. Now come to the next point, that how you are going to detect the spots. You will get the various spots, but it is quite possible that you will not be able to see the spots. First reason is they are colorless. So there are four ways by which we can see the spots. By natural color. Suppose we have done the pigments. The pigments, plant pigments are green in color. They have the color, so we can see those colors. We can do it. It's fine. But not, for example, if we are doing amino acids, if we are doing sugars, if we are showing nitrogenous bases, we are not able to see all those. For that, we need either the chemical reaction, where we will spray the anhydrine or analytical reagents, and these reagents will go and bind to the spots. Wherever there's a spot, they will form a colored complex and we will be able to see. First factor. Second, by fluorescence. For example, in case of nitrogenous bases, we can use a UV transilluminator to see where they are fluorescing. So by using different mechanism, we can detect the spot. After detecting the spots, we have to calculate the RF. RF is nothing but distance traveled by solute and distance traveled by the solvent. So you have to calculate the distance traveled by the solute divided by the distance traveled of the solvent. This is the solvent front and this is the distance traveled by the solute. For example, you can see here we got different spots, x1, x2, x3, x4, xy. So y is your solvent front, so we have to calculate the RF, which is x upon y. So for individual spot we can calculate the RF. It is always less than 1 and it is unitless factor. So we have to calculate the RF. The main purpose of doing this chromatography technique is to find what is there in the unknown mixture. So whenever we will run the chromatography, we will always have a standard. This methionine, arginine, leucine, alanine, they act as a standard, and the one here is a mixture of unknown amino acids. So whenever we are running the chromatography, we will have amino acids known, which acts as a standard, and this is a mixture. Whenever we will run it, we will get different amino acids bands, and you can see via this technique that what is present in the mixture. You can see that this spot corresponds to this because it is same in color, same as distance travel, so this is definitely arginine. And here in this case also it is definitely leucine. So out of these four unknown amino acids, I am able to detect only two because I have run four as a standard. Out of so many amino acids present in the nature as well as in the plants, I have run 4 amino acids, so I was able to detect only 2. If I have run 10, so I could have detected these two also because they are having different colors, different RF, so I am not able to detect these. This is the way we can done to the paper chromatography. There are various factors which affect the RF value: temperature, purity, distance travel, saturation and all, pH of the solution. So we have to. So with this, I want to thank you all of you.